Hey guys, it's time for your last video for this whole packet. It's on energy transformation, so label the paper energy transformations and plop a date on there. I noticed our notebooks have been missing dates.
Yeah.
We all like having dates. Put a date on there.
All right, let's get this party started.
Okay, first thing is a brainstorm. I want you to make a list of the 7, well, you know, there might be more than 7. Sometimes I read there's 9. Sometimes there's 6. But we're going to go with 7. There's 7 types of energy that we use in the world. What do you think they are? Pause the video, make a list right now. Welcome back. Here are the 7 types of energy that we'll talk about. Occasionally they'll break these up a little differently, but we like it this way. So we have mechanical, heat, light, sound, electrical, chemical, and nuclear.
So if you need to pause the video to make this chart, do it.
How do you make straight lines, by the way, Burkhart?
Ooh, there's this thing called a ruler.
Ruler. Yep, use a ruler and skip probably about 2 to 3 lines in between each one. Okay, pause the video. Get her done.
Welcome back.
Hi, we're still here.
Okay, so mechanical energy is the first one we want to talk to you about. And mechanical energy is really just the energy of any type of movement, motion. So when you're walking, when the blades of a fan are spinning, what are some other ones?
It could even be like a leaf falling.
Yep.
So any sort of movement. It doesn't have to be a machine doing the movement. It could be anything moving like our bodies.
Right. Exactly. Yep.
So it's the energy of motion.
Mm-hmm.
Okay, next up, heat. It has an alias. It's also known as thermal energy. So, like, I heard the word thermal before with, like, thermal underwear.
Mm-hmm.
And it keeps you, like, nice, warm, and toasty in the winter.
And thermal cameras that heat,
Oh,
pick up heat that living things are giving off. So a lot of people use them when they're hunting, or the military uses them.
So this is just the energy of heat. And here's examples: a blow dryer, oven, fire, candles.
You give off heat too, though. So if you ever, you know, that's why sometimes when it's really cold outside, or when you are in a car that's cold, and yeah, so like your breath and your body heat then fog up the windows. So
technically, everything has thermal energy. Even like an ice cube has a very minuscule amount. It's just, it feels very cold because it doesn't have that much heat.
Minuscule means small.
Yeah, teeny tiny.
Okay, light energy, pretty self-explanatory here. Anything that gives off light is using light energy. So the sun, a light bulb, your phone when you turn the backlight on, fire alarms that have the flashing red light on it, all light energy. And
we will learn a fancy pants word for this later, which makes you sound totally way smarter than you are. It's called electromagnetic. You throw that in a conversation, people are like, dude, who's that brainiac? But electromagnetic is also another name for light.
Yep.
But you'll learn it like November.
Sound energy, one of the easier ones too. Anything that makes sound, then that's sound energy. So us talking right now, the way that your feet make a noise when they hit the hallway, your locker closing, anything that's sound energy.
And if you think about that, that sounds like right now you're listening to our lovely voices and you're leaving the speaker of your device, and that sound wave has to leave from the speaker to your eardrums. So that does take energy to go that distance.
Mm-hmm.
Okay, now we're halfway done. We got 3 more to go. Electrical energy, the one we just studied. Woohoo! Is your energy from a moving electrons. Like, it takes energy for those electrons to go through the wires or whatever circuit you're talking about. So it's basically electricity.
And this connects back really easily to, you just finished conductors and insulators not too long ago. So remember, conductors were the ones that allow the electrons to move really easily.
True that.
And insulators, the electrons do not move.
No go. So your examples are like circuits, fridge, fans, wires, anything that has electricity in them would be using electrical energy.
So things that plug into a wall socket, or things that
battery operated.
Are battery operated. Mm-hmm.
Okay, the last 2 are the hardest 2, and they also often get mixed up with each other. So listen extra carefully. So chemical energy. The definition again isn't very scientific. It's just energy stored in chemicals. But what does that mean? Chemicals aren't necessarily what you think about with the mad scientists mixing potions. I mean, that is a chemical, true that. But I said that a lot today.
You do. You're on
That's
that.
really weird. Things that you use in life are like batteries. Inside the battery are chemicals that store that energy ready to push those electrons through. Or the food that you ate. If you had a granola bar today, then that granola bar is storing energy in the form of calories, actually, that you will then utilize later in the day.
So think of things that when they're just sitting there, they're not at work. So like a battery just sitting on a shelf is there. Something has to happen in order for the chemicals to actually
Perhaps
create the energy.
chemical reaction.
Very good.
Ooh.
Which you should have learned about, I think, last year.
I think so.
So,
Unless they switched it.
so like the medicine that you take that are like tablets or in pill form, they break down in your body to then provide whatever medicine it is you're taking.
And then here's the one that's the trickiest to understand. It's called nuclear energy. And it's actually stored in the atom, and specifically in the nucleus of the atom, which is why they call it nuclear. You do not see this other than looking at the sun, which you're not supposed to look at the sun. But you won't see this on a daily basis, just living your life.
No.
It's the sun. It are nuclear power plants. It's the atomic bomb. Because that neutrons and protons are held so tightly that when you break them apart, this massive amount of energy is released. Like bigger than anything you can imagine, energy is released. And that energy goes somewhere in the form of like light and heat and sound. It makes a big boom.
Mm-hmm. And because of the amount of energy that goes with the word nuclear, a lot of times one of the downfalls of nuclear energy is radiation.
Right.
Which radiation is used in cancer patients, so it's very potent, very powerful, which you'll learn more about that when we get onto the EM spectrum more.
Yeah. Okay, so let's practice that. That were the 7 types of energy. So let's talk about each one. Let's practice this. So I have 6 pictures here. I want you to list the pictures. There's pizza, a guy with a remote control, elephant with a drum, a sun, a flat iron, and a slinky. In a second, I'm going to have you pause the video, and I want you to list at least 1 or 2 energies that are associated with each picture here. Mm-hmm. And here's your choices again, okay? So you're just going to write down pizza and then whatever energy goes with it. So pause the video right now. Hi, welcome back. Woo-hoo. Okay, so I'm going to show you the answers real quick. So most of these have more than one type of energy associated with it. Do you want to hit any highlights here?
No, just keep in mind that when you're thinking about most objects, one single answer very rarely, if ever, occurs. So when you're taking the test and it's asked you to name the type of energy transformations that are occurring, there's normally more than one correct answer. So just think through the entire object as a whole.
Okay, we have more practice. Oh, not a practice, a statement. This is still to be proficient. You need to understand this. This is the law of conservation of energy. It's a law, which means it's bigger than a theory. A law means they're pretty much certain that it's going to happen, and no matter what situation, it's been true. Mm-hmm. So scientists pretty much say this is a true statement. So here's the statement. Energy cannot be created or destroyed. It can't. All the energy that we will ever have in our world, in our universe, has already been created. It's just going to be converted from one form to another. So for instance, in your circuits, you use chemical energy stored in a battery to convert to electrical, and then that turned into light, and sometimes the bulbs got hot, so that turned into heat.
Yep. And then that heat is released into the air around you, which then is transformed into other types of energy depending on where it goes and what it does. So everything that happens, all the types of energy you just learned about, it doesn't disappear. So even when that battery is dead and it no longer works, it's because the energy that was once in that battery has been transformed into other types of energy. It's not because we have lost energy. And when you get a new battery, you're not creating new energy. The chemicals inside that battery came from somewhere else in order to have that energy. So
it's a big cycle. Okay, so now we have different objects. What kind of energy do these produce? So
I like it.
Make a list, a T-chart, chemical light, and put these items in that. Pause the video. I'll show you the answers in a second. Okay, you should be done making your little T-chart. Oh, can't find a link. Okay, so These produce. This produces light energy. This produces light energy. This produces chemical energy. And this one, I would say, produces light energy. Most calculators have a backlight, not all. Some of them would fall into the chemical, depends on the type of calculator.
Yeah, if you're using a solar-powered calculator, would you count that as chemical then? Because it uses the solar power to...
It just produces electrical. It wouldn't be chemical.
Oh, yeah.
It needs to have a backlight to be light energy.
See, sometimes you need to talk through these things. So say it out loud.
Say it out loud. Okay. We already talked about this. Since energy can't be created or destroyed, its energy is transformed. That is the word you will see on assessments. Transform. If I was a transformer, I go from that bumblebee guy to the truck. I transformed my shape. Energy changes and transforms its type from one type to another.
And what she means by bumblebee guy, I believe that is a Shelby.
No, the big yellow bumblebee guy.
Right.
Isn't his name Bumblebee?
The car, but the Shelby car transforms to Bumblebee.
Okay. I didn't know. That was a truck.
No, he's like yellow.
Yeah, a yellow truck.
No, it's a sports car. Don't listen to her. I'm pretty sure it's a Shelby.
I hate that movie. Okay, sorry guys. Okay, we're almost done. Identify the different kinds of energy that these electrical devices produce. So you got a drill. And this is a drill you find in your parents' like shed or garage. And then you have a really old picture of a computer. This is what they used to look like back in the day. So what do they make? They take electricity and they produce, each of them produces 3 different things. Let me grab my eraser. Let's get the big one.
So it's really important that when you're doing these practice ones that you read the statement correctly and thoroughly. So we're asking what type of energy that the devices produce, not what type of energy the devices use.
Right. So obviously the drill thingy spins. So that's mechanical. Now, can you hear a drill?
Yes, absolutely. They're pretty loud.
Those are 2 obvious ones. Now you have to think about the drill itself. What happens when you use that drill after a while?
Well, I have actually touched a drill after using it,
Ouch.
and it's pretty hot.
Heat is a side effect of many transformations. Your desire isn't to heat up a room using a drill, but that just happens. It's kind of wasted energy.
And sometimes the newer drills have actually a light on the front of them. So if you're drilling someplace that's kind of dark, you hit the light.
I wouldn't drill in the dark.
Yeah, but what if you're like in a closet or something, putting something in, and there's not a light?
I don't know. Okay, that's kind of weird. Here's the computer. Most computers have some sort of speaker system, right? So they make you some noise, some sound. Even you can hear the fans running in the computers.
Yep.
Then, again, the computers get hot.
Singing, ha.
Another wasted energy. Because your computer, again, isn't purposed for it to be hot. It actually is bad for the computer.
Yep.
But it's there. And then, obviously, your lights, because there's lots of lights and stuff in a computer.
Yep.
So there's 3 transformations. Again, heat is always usually made, but not intended. All right. So electrical energy is found in most everyday, or many everyday objects, not most. The electricity is converted from one form to another. I want you to finish these sentences. It's the last thing you have to do. A fan transforms blank energy into blank energy.
So pause the video and go through each one of these. Write the whole sentence. Don't just write the word. Write the whole sentence into your science notebook and then come back and we'll give you the answers.
Okay.
Welcome back.
So now let's show you the answers. I gotta get rid of the eraser. How do I get rid of the eraser? Okay, there we go. Let's check your answers. The fan turns electrical energy into mechanical energy. That's the main, and there might be other energies that the fan makes, but this is
like
the main one.
Sound energy, because you can hear the blades going.
Yeah.
Heat energy.
The flower transforms sunlight into chemical energy, or you could have just taken light into chemical energy, because the flowers make its own food. That was a harder one of all of them.
Yeah, because if you don't remember much about photosynthesis or you haven't learned about photosynthesis yet, that would have been tough.
Tricky. And the stove is pretty tricky too. This stove happens to be a stove that makes the flames. There's 2 types of stoves. My stove does not make fire at home. It used to, but mine has the flat top. So that would have been a different answer. This one is the one that makes the flame. So fire is chemical energy. and that makes light and heat.
And there are some other ones, like the flower, if you put it transforms light into mechanical energy, that would be correct because the flower grows.
Oh, didn't think about that.
So if you have something different, feel free to come talk to us and see if what you have is a possible answer.
Yeah. Okay, guys, that's it for energy. If you have any questions, like she said, come find us.
Hasta la vista.